Hello geometry students, here's your lesson for section 1-5, using formulas in geometry with Missy McCarthy, math instructor at Okemos High School. By the end of the video, hopefully you will say, I can recall and apply formulas for perimeter and area of rectangles, squares, and triangles, and I can recall and apply formulas for circumference and area of a circle. So because we want to recall and apply formulas for the perimeter and area of a rectangle, square, and a triangle, we first need to look at these particular shapes and see what those formulas are and how they were developed. So for the perimeter of a rectangle, let me get my black pen, I do have it. All right, the perimeter is the distance around the rectangle. So if these two are congruent, they're both L. And if these two are congruent, they're both W. So the distance around the perimeter would be W plus L plus W plus L, which if we were to simplify, the perimeter around a rectangle is 2W plus 2L. And that is going to be the equation that we use for perimeter. The other formula that we need is the area, and we get the area of a rectangle by multiplying its length times its width. So the area of the rectangle is going to be L times W. A square is actually a rectangle, so we're going to use a similar formula, although these are all S, because all four sides of a square are congruent. So for our perimeter of a square, it's just going to be 4S, the distance all the way around the square. And in the area, again, is going to be similar to that for a rectangle, but because they're both S, it's going to be S times S, which is S squared. Lastly, for a triangle, the perimeter of a triangle with sides ABC is just going to be A plus B plus C, and the area of a triangle is going to be equal to 1/2 the base of the triangle times the height of the triangle, where the base of the triangle is right along the bottom, and then the height is always drawn perpendicular to the base through a vertex. So just a little reminder here about the base of a triangle. We're going to call the base B, and it can go to any side of the triangle, but we need to just pay attention to where the height is drawn. So the height is the segment from the vertex that forms a right angle with a line containing the base, not necessarily the base itself, but a line containing the base. So if we have this as a base here, and from this vertex straight down forms the right angle, then that means that's the height of the triangle. But if our base is now here, and here's the vertex going straight down perpendicular to the side, then that would be the height of the triangle. Lastly, if we have a triangle with an obtuse angle, your base is here. Your base does not extend out to that dotted part. But your height has to start at this vertex, and it has to come down perpendicular to, that's why they said a line containing the base. So the height can come down and be on the outside of the triangle, but the base is still just that side of the triangle. So applying those formulas, we have here a rectangle, and we have to find the perimeter and the area of the rectangle. So perimeter of the rectangle is 2L plus 2W. We're given 2 times 6 plus 2 times 4. So that's what's given to us in the diagram. 2 times 6 is 12. 2 times 4 is 8. And we get that the perimeter is 20 inches. Don't forget your units. For the area of this rectangle, I'm going to do area equals length times width. Area in this case is equal to 6 times 4, and area would be equal to 24, and the units is inches times inches, so it's inches squared. For B, all of our side lengths have a variable in them. They're x. So our expressions for perimeter and for area will also have an x. So the perimeter is going to be equal to the sum of the three sides, x plus 4 plus 5x plus 6, which is going to give us 6x plus 10, and we don't have units, so I'm going to say units. Be very generic. Now the area of this triangle is still 1/2 the base times the height. The base of this triangle is 6, and the height of this triangle is x plus 4. So it's 1/2 of 6, which is 3 times x plus 4. Do the distributive property, and you get 3x plus 12, and the units would be, this case, units squared. Our second learning target says that we can recall and apply formulas for circumference and area of a circle. So circumference is another word for perimeter. If you have a shape with sides, you call it perimeter. If you have a shape with a round like a circle or an oval, perhaps, you call it the circumference. So our formula for circumference of a circle is here. Circumference of a circle is equal to pi times diameter, or because the diameter is equal to 2 times the radius, you could say circumference equals 2 times pi times r. And you have a diagram here, and be sure you know how to identify the parts of a circle. You've got to know what the diameter is. You've got to know what the radius is. For the area of a circle, we use the formula A equals pi r squared. So in this particular problem, it says, can you find the circumference and the area of a circle whose radius is 8 centimeters? So I am going to draw my circle. The radius of my circle is 8 centimeters. You don't have to draw the circle, but I like visual, so I drew it. The circumference then of my circle is equal to 2 times pi times the radius, which is 2 times pi times 8. 2 times 8 is 16, so we get 16 pi centimeters. Now I could use the pi key on my calculator to round to the nearest hundredth or tenth, as they said, but I don't have a calculator handy, so I'm going to let you do that. And then the area of this circle is pi times r squared, which is pi times 8 squared, which is 64 pi, and my units would be centimeters squared. And again, I do not have a calculator handy, so I will let you use your pi button on your calculator to round to the nearest 10. So just to recap, make sure that you can recall, and that means memorize, the formulas for perimeter and area of rectangles, squares, and triangles, and also recall and apply. That means memorize the formulas for circumference and area of a circle. See you in class.